Dear students, I welcome all of you for the chemistry revision class on 20th, 22nd January 2021. The last period, dear student, we have revised. In the last period, we have studied about the chemistry of brown ring test. Now today, let us study further. So first we should know which type of nitrates do not give brown ring test or brown ring. This is what we should even know, that there are some nitrates which do not give this brown ring, and these nitrates are: number one, lead nitrate, PbNO3 twice, lead nitrate. Second one is barium nitrate. The third one is calcium nitrate. These are the three nitrates which do not give positive brown ring test. Now, what is the reason why they do not give positive brown ring test? What is the reason? So they do not give this test because when these nitrates reacts with H2SO4, which is known as sulfuric acid, they give corresponding sulfates, and thus they do not give the brown ring test. Now, my dear students, we want to study about the various uses of nitric acid. Which are the various uses of nitric acid? Let us study the uses of nitric acid. What could be the various uses of nitric acid? That is what we need to understand. My dear students, first use we can write for our nitric acid is nitric acid is used in the preparation of ammonium nitrate. In the preparation of ammonium nitrate and other fertilizers. So this is what it was this is what it is the first important use of nitric acid, that nitric acid is used into the preparation of the ammonium nitrate and other fertilizers. It is also used for making the explosives. So some of the explosives are also prepared by this particular. It is also used for the preparation of the trinitrotoluene, which is an explosive. So it is used into the preparation of explosives like TNT or trinitrotoluene. The structure of trinitrotoluene is this way. You can show the trinitrotoluene. This is 2,4,6 trinitrotoluene. That is what it is known as TNT, which is a very important explosive. This nitric acid is also used for the pickling of stainless steel. So we can write pickling of the stainless steel. Pickling of the stainless steel. Then the next use is, my dear students, is for the etching of metals. Fourth use we can write for etching of metals. And the last one we can write it as an oxidizer into the rocket fuels, as an oxidizer in rocket fuels. So please remember, my dear students, these are the various uses of our nitric acid, and by using this various uses, we can complete our discussion about the nitric acid. Now we can move to study about the another element of group 15, which is known as the phosphorus. So let us start our study about phosphorus. Dear students, can you see I have written phosphorus on the screen?
Yes, sir.
Thank you. Thank you for
Yes, sir.
replying. Thank you.
Yes,
So
sir.
this phosphorus, first we need to study about the phosphorus, and phosphorus found into the many allotropic forms. So first we want to study about the allotropic forms of phosphorus. If we really look into the various allotropic forms, my dear students, we realize that this phosphorus has got two major allotropic forms. Let us study them one by one. The first allotropic form of phosphorus is known as the white phosphorus. We may have white phosphorus, and the another allotropic form that we want to study is known as the red phosphorus. So let us study one by one about this white phosphorus as well as about the red phosphorus. We will study them comparatively so that we can remember them well and we can understand even them well. So let's start with the white phosphorus. White phosphorus is actually a translucent white waxy solid, whereas red phosphorus is red colored, or my dear students, we can write iron gray lustered, iron gray luster solid. So both are solid and both have the color, or we can say white color is not color. So it's a white phosphorus is translucent waxy solid, whereas red phosphorus has got red color. That is what we can realize. Then, my dear students, our white phosphorus is poisonous, whereas red phosphorus is non-poisonous. Then, dear students, we have white phosphorus is insoluble in water. White phosphorus is insoluble in water, but soluble in carbon disulfide, but soluble in carbon disulfide. Please remember, our red phosphorus is insoluble. Red phosphorus is insoluble in both, that is, water and carbon disulfide. So this is how we understand the basic differences between our white phosphorus and red phosphorus. Next, we can say that our white phosphorus exists as a discrete molecule. That is how I can show you this white phosphorus. So we can have white phosphorus in this manner. This is white phosphorus. A white phosphorus has got this angle. This angle is 60° for our white phosphorus. Please remember that for white phosphorus, this angle is of 60°. This is 60° angle for this white phosphorus. These all are P. So they are. So we can write that white phosphorus exists as discrete P4 molecule. You need to understand that this white phosphorus exists as a discrete P4 molecule, my dear students. But when we look at the red phosphorus, what we realize, let me explain, my dear student. Let me first draw something for you so that you can understand it well. This red phosphorus exists in this way, as I have been trying to show you in the figure. We can see that this is how the phosphorus atoms are being connected to each other. This is how it really works. These all are your phosphorus atoms. So this is how, my dear students, we understand that our red phosphorus exists as a polymeric. This red phosphorus exists as a polymeric large molecule. Now, if you look into this, my dear students, you realize that when you have white phosphorus that exists in a polymeric, red phosphorus exists in a polymeric form. Now, what you understand here, my dear student, is something that is very important as well as interesting for us to study. That when this phosphorus, exists in this particular manner, can you see the screen, dear students? What you can see on
Yes,
the
sir.
screen? Okay, good one. So,
Yes, sir.
and you can see the new molecules and I hope you see that I have generated the new page. बच्चों, आपको जो नया पेज बनाया है मैंने, वो दिख रहा है?
डायग्राम दिख रही है।
मैं अभी कुछ लिख रहा हूँ, जिस पेज पे वो पेज दिख रहा है?
हाँ हाँ
हाँ या ना?
यस
दिख रहा है ना?
सर
Yes, sir.
Sir.
वेरी गुड। मैं अभी जिस पेज से लिख रहा हूँ वो आपको दिख रहा है ना? वेरी गुड, वेरी गुड, वेरी गुड। चलिए, so again we will discuss. Now you can see that here this is the white phosphorus, this is what we are talking about, the red phosphorus. Here when you look into the white phosphorus, you realize that this is a very small angle. P bond P angle is 60 degree. So due to very small angle P dash P, white phosphorus has angular strain, my dear students, has angular strain. Due to polymeric nature, red phosphorus does not have angular strain, You have seen, my dear students, that red phosphorus actually exists. Red phosphorus contain P for tetrahedral links. Red phosphorus contains P for tetrahedral links. Now you can see in this structure that this angle, which was 60 degree at once, has been changed and the angle has been increased to the greater size. These all angles were 60, but here this angle has been increased. It is more than 60. So thus the angular strand has been decreased into the polymeric nature of red phosphorus, and due to this what happens, my dear students, that white phosphorus is less stable. Why it is less stable? It is less stable due to the angular strain. So white phosphorus is less stable due to the angular strain, thus more reactive. So our white phosphorus is less stable and more reactive, but when we compare the red phosphorus, compared to red phosphorus, then red phosphorus is more stable and less reactive. This is what we have discussed about the chemical nature. So this is what it is, the chemical nature, chemical or chemically. This red phosphorus is more stable and less reactive. White phosphorus is less reactive and white phosphorus is less stable and more reactive. And that is why, my dear students, there is a process or there is a phenomena known as a chemiluminescence. This chemiluminescence is shown by white phosphorus. That means it glows in dark. But if you look into the red phosphorus does not glow in dark. That means red phosphorus does not show any chemiluminescence, and thus red phosphorus does not glow in dark, my dear students. This is what we understand about the white phosphorus and red phosphorus. Dear students, can you see the line I have drawn on the screen? Bacho?
Yes.
Okay.
Yes,
So the
sir.
screen is empty for you right now. Am I right? Screen is empty for you right now. स्क्रीन पे
Yes.
कुछ लिखा हुआ नहीं दिख रहा है
नहीं
ना?
नहीं कुछ भी नहीं दिख रहा था ना.
Okay, that's good. So now we can say that red phosphorus is more stable. Red phosphorus we have seen that red phosphorus is more stable and white phosphorus is less stable in the nature. So as this red phosphorus is more stable and white phosphorus is less stable, white phosphorus easily catches fire. This white phosphorus easily catches fire and it forms dense white fumes. Right? Phosphorus easily catches fires and forms dense white fumes and forms dense white fumes, my dear students. These dense white fumes are because of the reaction of phosphorus with oxygen present in the air, and that produces P4O10. This P4O10 gives the dense white fumes. My dear students, there is one more reaction that we can study about the white phosphorus is that white phosphorus is soluble in boiling sodium hydroxide solution and it gives us phosphine. So white phosphorus is soluble in hot NaOH. It gives
Hay mas tama kalakakan din.
it gives phosphine. pH3 in the inert atmosphere. In the inert atmosphere. Please remember, Let us write the chemical equation for this, that P4 plus 3NaOH plus 3H2O, that gives PH3 plus 3NaH2PO2. Now here it is very interesting thing takes place, my dear students. Here your phosphorus is in the zero oxidation state, that turns into -3 and +1 oxidation state. So you can see that here this is the reduction, here this is the oxidation. But reduction and oxidation takes place for the same element, and this is the disproportionation reaction. So this is the disproportionation reaction. Please remember, my dear students, that red phosphorus does not give any such reaction due to less reactivity. So this is how we can prove, or we can understand, that our red phosphorus is actually uh, less reactive than the white phosphorus, and thus red phosphorus does not give any kind of reactions that white phosphorus can give. So this is how, my dear students, we study about the white phosphorus and red phosphorus. Let us discuss little more about the white phosphorus and red phosphorus. But before we move to that, let me introduce the another form of phosphorus, which is known as the black phosphorus. So this is the another allotrope of phosphorus, which is known as the black phosphorus. This black phosphorus exists in two forms. One form is known as the alpha black phosphorus, and the second form is known as the beta black phosphorus. So my dear students, we have alpha black phosphorus and beta black phosphorus. Now how do we prepare this various things? Let us study about them. So what do? We take red phosphorus. So we take red phosphorus. This red phosphorus, dear student, is heated in a sealed tube. So we will heat it. We heat in a sealed tube. In a sealed tube at 803 Kelvin. So my dear students, when this red phosphorus is heated in a sealed tube at 803 Kelvin, we simply get the alpha black phosphorus. Now my dear students, suppose we take the white phosphorus. White phosphorus and this white phosphorus is heated. This white phosphorus, my dear student, Can you see the screen clearly, dear students? Hello.
Yes, sir.
You have
Yes,
seen that
sir.
I have written heat.
Yes, sir.
Okay, so white phosphorus, when it is heated at 473 Kelvin, if it is heated at 473 Kelvin under high pressure, my dear students, we get the beta black phosphorus. So we will get here beta black phosphorus. So this is even the difference between the red phosphorus and white phosphorus. That white phosphorus gives black beta black phosphorus, whereas red phosphorus when heated gives alpha black phosphorus. This is the basic difference that we can understand about it. Now let us understand a little more about our alpha black phosphorus and beta black phosphorus. So first thing that we should know about alpha black phosphorus is it has got the opaque monoclinic, opaque monoclinic, or it has got the rhombohedral crystals. So either it can have opaque monoclinic crystals or it may have rhombohedral crystal. And another important thing about this is alpha black phosphorus does not oxidize in the air, does not oxidize in the air. Then what about the beta black phosphorus? This beta black phosphorus does not burn in air, does not burn in air up to 673 Kelvin. After 673 Kelvin it can burn in the air, but up to 673 Kelvin this beta black phosphorus does not burn into the air. So this is how, my dear students, we can study about the various allotropic forms of our phosphorus. Now if you have any doubt you can ask me. Dear students, do you have any doubt about the various allotropic forms of phosphorus?
No.
No, sir.
Very good, very good. Then let you go for the next class. Okay,